So we have a question where trigonometry as well as the concept of functions are simultaneously involved. So we are given a function fx is equal to cos of x minus k, where x is varying from 0 to a and k are positive real numbers. Now we are given that if k is equals to pi by 2, we have to identify the largest value of a for which the function or the inverse exists. So what do we mean by inverse? Inverse, basically in a function there is a domain and there is a range. So there is a mapping from domain to range. So when inverse has to exist, we have to understand that it is possible that two of the inputs have a single output. For example, in case of y equals to x square, x equals to minus 2 and x equals to plus 2 will have same output. But for inverse to exist, this case is not acceptable, because in this case, if inverse is to exist, a single input will have two outputs, which is not possible as per the definition of a function. So for an inverse to exist, it is must that one-to-one mapping should be there. So having known this, now let us try to solve the part A. In the part A, since k is equals to pi by 2, so we are given fx, which is cos of x minus pi by 2. Now we know the graph of cos x is something like this. This is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. And now if we have to draw the graph of cos of x minus pi by 2, we replace x by x minus pi by 2, and hence the transformation of x to x minus a is applied. So the whole graph will get shifted towards right by pi by 2. So we shift this graph by pi by 2. So this graph must have been on this side also. So if you shift the whole graph by pi by 2, what we will get is a graph something like this. Something like this. So what we get is a graph of similar to a sin x. Now from this graph, it is very clear that the maximum this graph can be inversed is from 0 to pi by 2, because after that there will be two values of y having same input of x. So maximum a can be up to pi by 2 for this function to be inverse. Maximum up to only pi by 2. Now let us try the B part. In case of part B, value of k is pi. Now the function fx is cos of x minus pi. As we have done in the past, we will try to draw the graph of cos of x minus pi. So first let us draw the graph of cos of x. So the graph of cos of x is something like this. So this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. This is minus pi by 2, this is minus pi. Now we know from the transformations that to obtain the graph of cos of x minus pi, we can use the graph of cos x by shifting x by x minus pi. And as you shift x by x minus pi, the whole graph gets shifted to by right by pi units or a units. So the graph gets shifted by pi units. So this point will come here. So this graph will become something like this. And now if you see, from 0 to pi, this graph can be inverted. inversed, but after that there will be two values for which we get a same output. So the one-to-one mapping will not be after the pi, but it will be there up to pi. So maximum A can be equals to pi. Similarly, in the C part, what we are asked is that in terms of k, where k is less than 2 pi and greater than pi, we have to identify the value of A, for which the inverse exists. So we know the graph is cos of x minus k. So the maximum A can vary is up to pi and minimum it can be 0. For an interval of 0 to pi only, the cos graph will be inversible. So since k is varying from pi to 2 pi, we can write A equals to k minus pi, such that when k is equals to pi, it will be equals to 0, and when k is equals to 2 pi, near 2 pi, A will be equals to pi. So that A can vary from 0 to pi. 0 and pi, since k is not equals, k is varying between 0 pi and 2 pi, A will also vary between 0 and pi. The equality is just for identifying the answer. So our answer will be A is equals to k minus pi. So for similar such questions, do register on our website www.iitnacademy.com and register for the solutions. Thank you.